Alright, this is section 1-3 in Algebra 2, solving compound linear inequalities. We start with a compound linear inequality. For definition means that it's got two inequalities in the equation. So you can see that this one has two, example 2, there's two inequalities, and so on. And each of these will be two inequalities. Now, whoops, didn't want to do that. Get my picture back. Okay. Now, so we have compound inequalities. A conjunction, generally speaking, has an and statement. And what you see with a conjunction, those are written as one inequality. For example, example 1 then is a conjunction. Okay. And we know, because it's written as one inequality, that it's a conjunction. But the other way, generally speaking, is that the inequalities you see will be less than or equal to. And so one way to recognize a conjunction, if you think about it, less than and is an and statement. So less than an or an is a conjunction, which is an and statement. It will be your answer in an and statement. Your answer is going to be written as one equation. So your answer will be one compound inequality. Okay. Now, disjunctions, and we are going to see in this case a disjunction is an or statement, and it starts with two equations and ends with two equations. For the disjunction, you're going to have two inequalities or two equations as your answer. Okay? For a disjunction. That's the difference in the way you report the answer. When we see, not so much in this example, but as we go forward with absolute value, conjunctions are less than or equal to, and disjunctions are greater than or equal to. That's when you don't see two separate equations to start with. When you see two separate equations to start with, you're going to assume that it's a disjunction, and you'll find out that it graphs that way. So, another difference is the way they graph. When you graph a conjunction, it's going to graph with two endpoints, and the shaded area is going to be between those endpoints. When you graph a disjunction, you have your 2 points, and the arrows, the shaded arrows, will be pointing away from each other. Okay. So let's work these problems. In this inequality, you're going to solve it as though it's just an equals, the way you solve an equation, but you have to go across both of the inequalities. So you're going to subtract 3 in this middle section, and that's going to make that piece add to be 0. But what I do there, I have to also do to each side across each inequality. So now we have -8 is less than 2x, which is less than 12. You'll divide by 2, and we still need to worry about reversing the signs if we have to divide by a negative. 2 is not negative, so we don't have to worry about that. So you have -4 is less than 1x, which is less than 6. So when we graph it, Again, mark your 0. Your -4 is going to be on the left of the 0, and 6 is to the right, a little farther away than the -4. We don't have a scale, but proportionally try to put them on that number line. It's less than, so there is no line underneath there, so it's an open circle on the -4 and the 6. And we shade between the two because X is all the numbers between -4 and 6. And that's the solution set. Looking at example 2, solve it the same way. Add 7 across. That 7 adds to be 0. This 7 adds to be 0. So we have 0 is less than or equal to 3/4 X, which is less than or equal to -4. We need to multiply by 4/3 to clear the fraction. So we have X in the middle now is less than or equal to, we have a 0 here because anything times 0 is 0. And over here we have -16/3. Alright, so we go and we want to graph that. And I did something wrong, so let's go back and try this again because I just realized I made a mistake. Let's see if I can get the eraser to come on. Here we go. So we're going to add 7 just like we did before. I didn't add 7 there. I just brought down the -4. So this is 0 less than or equal to 3/4 X, which is less than or equal to 3. I have to add the -4 and 7. Now we multiply by 4/3. Okay. So that times 0 is 0. It's less than or equal to X, which is less than or equal to, these 3's cancel, so that's a 4. Now put on a number line. We have a 0 and a 4. They're both less than or equal to, so it's a shaded circle. And draw the line between them. Alright, on the example 3, this is the last conjunction we have. We have -4 is less than or equal to -X plus 1 is less than 4. We have to go ahead and distribute that negative. Now subtract 1 across those inequalities, and we have -5 is less than or equal to -X, which is less than 3. Now in this case you're going to multiply or divide by -1 in order to make that a positive X, which gives us +5. Since we multiplied or divided by a negative, we have to switch the sign around. A positive X, reverse this sign, and that's a -3. Now it's important when you have these conjunctions and you write them as one equation, I want you to write the answers. I want you to put your answers in what I call number line order. Okay, so what that means is you've got to put your lowest number first, and your lowest number is a -3, and you have your X and then your 5. Now you have to be sure that you get your signs right when you rewrite it. So this X, between the X and the -3, the sign is pointing to the -3, so we have to point it to the -3. And between the X and the 5, it's pointing towards the X, so we're going to rewrite the symbol that's there pointing towards the X. So So we have negative 3 is less than x, which is less than or equal to 5. So we put on our 0, our negative 3, and our 5. It's an open circle on the negative 3, and a closed circle or a shaded circle on the 5. And the solution set is between those two because it's a conjunction. Now we go to disjunctions. We know in this case, if you look down here at the bottom, disjunctions are not written as one statement. They're going to start out and end up as two separate inequalities with an or, with the word or between them. Greater, later when we do absolute value, greater or goes together. Okay, two separate equations, solve them like we did in the section 1-2. Subtract 7 across here, and you're going to have x plus, when I subtract 7, you're going to have x is less than negative 3. And on this one, when you subtract 7, you have negative x is less than negative 6. Multiplying by negative 1, you have positive x, is greater than positive 6. Okay? And so this is your answer. X is less than negative 3, or x is greater than 6. When you draw it on your number line, you have your negative 3 here, your 6 here. Greater than and less than, so they're open circles. And then less than 3 you shade to the left. And greater than 6 you shade to the right. Okay. Our last example. Again, an or, so we know we're going to have two equations in our answer. Add 1, so you have 2x is less than negative 8, so x is less than negative 4. So put your negative 4 on your number line, open circle, less than, shade to the left. It's a disjunction. They should graph pointing outwards, pointing away from each other. So 3x here, add your 15 across, is greater than or equal to positive 15. So x is greater than or equal to 5. So 5 goes on the number line. This one is greater than or equal to, so it's a shaded circle, and it's going greater than will be to the right. And they do in fact point away from each other as they should. Okay. That's the end of 1-3.